Here are 8 circular saw blades that may look similar when mounted on a saw, but behave very differently once they enter the material. Choose the correct blade and the saw cuts smoothly, stays under control, and leaves the edge you expected. Choose the wrong one and the material can splinter, burn, chip, grab the blade, overload the motor, or turn a simple cut into a serious safety problem. The framing blade. This is the fast-cutting blade commonly supplied with handheld circular saws. A typical framing blade has a relatively low tooth count, often around 24 teeth on a 7 1/4-inch blade. The large spaces between those teeth are called gullets. They give sawdust and wood chips somewhere to escape while the blade moves quickly through construction lumber. That makes the framing blade suitable for cutting studs, joists, rafters, decking boards, roof sheathing, and other material where speed matters more than a perfectly smooth edge. Its low tooth count also reduces resistance and allows the saw to cut quickly without placing unnecessary load on the motor. But speed has a trade-off. Each tooth removes a relatively large amount of wood. That can leave visible tooth marks, rough fibers, and chipped edges, especially when cutting across the grain or through plywood. Use a framing blade for structural work, rough construction, and cuts that will later be hidden or cleaned up. Do not expect it to produce furniture-quality edges simply because the blade is new and sharp. The rip blade. A rip blade is designed to cut in the same direction as the wood grain. When wood is ripped, the blade separates long fibers along their length rather than slicing directly across them. This produces long chips that need enough space to escape. For that reason, rip blades normally have fewer teeth and deep gullets. The teeth take aggressive bites while the large spaces carry waste away from the cut. This reduces friction during long cuts and allows the board to move through the blade efficiently. Rip blades are commonly used on table saws when wide boards need to be divided into narrower pieces. They're useful for sizing solid timber and making repeated cuts along the grain. But a rip blade is a specialist. Use it across the grain, and the large teeth can tear the fibers instead of slicing them cleanly. The edge may show deep tooth marks and require sanding or planing afterward. Use a rip blade when speed and chip clearance matter. Do not choose it when the finished edge needs to look clean immediately. The crosscut blade. A crosscut blade is designed to cut across the wood grain. This requires the blade to sever thousands of fibers cleanly instead of separating them along their natural direction. To do that, a crosscut blade normally carries more teeth than a rip blade or framing blade. Each tooth removes a smaller amount of material. That reduces tearing and produces a smoother edge. The teeth are also arranged to slice the fibers from alternating sides of the cut. This makes the blade useful for trimming boards to length, cutting visible components, and producing cleaner results on hardwood and softwood. The difference becomes obvious on molding, shelving, furniture parts, and boards that will be joined without heavy sanding. But a more teeth blade also creates more resistance. A crosscut blade normally feeds more slowly than a low-tooth rip blade. Force it through the wood too quickly and the motor may slow while the blade begins rubbing and producing heat. Use it for clean cuts across the grain. Do not use it for long, fast ripping cuts when a dedicated rip blade would work more efficiently. The combination blade. A combination blade is designed for users who need to perform rip cuts and cross cuts without changing the blade constantly. It normally has a medium tooth count that sits between a fast rip blade and a fine crosscut blade. Its tooth pattern attempts to balance chip clearance, feed speed, and surface finish. That makes it the practical everyday blade for general workshop use. It can cut construction lumber, hardwood, softwood, plywood, and many common sheet materials with acceptable results. For a beginner with one saw and one blade, this is often the most useful starting point. Its biggest advantage is convenience, but a combination blade is still a compromise. It will not rip thick timber as quickly as a dedicated rip blade. It will not produce the same polished edge as a high-tooth crosscut blade. It performs both jobs reasonably well rather than performing either one perfectly. Use it for repairs, general carpentry, DIY projects, and jobs where versatility matters more than maximum speed or maximum finish quality. The fine finish and plywood blade. This blade is built for cleaner cuts on plywood, veneered panels, melamine, laminate, trim, and other material where chipped edges are difficult to hide. It normally has a high tooth count. More teeth mean each tooth removes a smaller chip. That spreads the cutting work across the blade and reduces the aggressive tearing caused by low-tooth construction blades. This is particularly important with plywood and coated panels. Plywood contains thin layers of wood bonded in alternating directions. Melamine and laminate have brittle finished surfaces that can chip as the blade exits the material. A fine finish blade slices those surface layers more carefully and leaves a narrower, cleaner edge. It's useful for cabinets, shelving, finished panels, interior trim, and projects where the cut surface will remain visible. But the high tooth count creates more friction. The blade must be allowed to cut at a controlled feed rate.
Push it too quickly and the motor may struggle. Move too slowly with a dirty or dull blade, and the teeth may rub the material long enough to leave burn marks. Support the panel properly and allow the blade to move steadily through the cut. The non-ferrous metal cutting blade. This blade is designed for metals that do not contain iron, including aluminum, brass, and copper. It may resemble a woodworking blade, but its teeth and cutting angles are designed for a much harder material. Non-ferrous metal produces sharp chips and places more shock on each tooth than ordinary wood. The blade, therefore, needs strong tooth support and a geometry that reduces the chance of grabbing the material. Many non-ferrous blades use a low or negative hook angle. This makes the teeth enter the metal less aggressively and helps keep the cut controlled. These blades are commonly used for aluminum extrusions, window frames, channels, trim, tubing, and sheet material. They can leave a cleaner edge and produce less abrasive dust than a grinding disc, but the workpiece must be clamped securely. A loose metal section can vibrate, move, or become caught by the blade. And remember that non-ferrous does not mean every metal. A blade designed for aluminum is not automatically suitable for steel. Always match the blade to the exact material and saw speed. The fiber cement blade. Fiber cement is one of the quickest ways to destroy an ordinary wood blade. The material contains cement, sand, and reinforcing fibers. That combination is extremely abrasive. A normal blade may begin sharp and lose its cutting edge after only a small amount of work. As the blade becomes dull, the user pushes harder. The saw produces more dust and heat, while the motor works under greater load. A fiber cement blade is designed specifically to resist that wear. Many versions use only a few large teeth instead of a complete ring of small woodworking teeth. Those teeth may be tipped with polycrystalline diamond, commonly called PCD. This material can last far longer than conventional carbide when cutting abrasive cement-based boards. These blades are used for fiber cement siding, backer board, exterior panels, and other cement-based building sheets. The low tooth count may look unusual, but it reduces dust and leaves more space for waste to escape. Dust control is essential. Use suitable extraction, respiratory protection, and the cutting procedure recommended for the material. The diamond blade. A diamond blade is used for concrete, brick, stone, tile, and paving blocks. It works differently from every toothed blade already discussed. Instead of sharpened steel or carbide teeth, its edge contains industrial diamond particles bonded into a metal rim. Those particles grind through the material as the blade rotates. A segmented diamond blade has separate cutting sections with gaps between them. Those gaps improve cooling and remove dust during aggressive cuts in concrete and masonry. A turbo blade uses an angled rim that balances cutting speed with a reasonably controlled edge. A continuous rim blade has no large gaps and normally produces cleaner cuts in fragile materials such as ceramic tile. The correct rim depends on the material and the required finish. A segmented blade may chip decorative tile. A continuous rim blade may cut too slowly during heavy concrete work. Some diamond blades are designed for dry cutting, while others require water for cooling and dust control. Always match the blade, material, saw, and cutting method. One blade detail matters across every type. The blade must match the saw. The diameter must be the size specified by the saw manufacturer. A blade that is too large may interfere with the guard. A blade that is too small may not reach the required depth or work correctly with the safety system. The arbor hole must also fit the saw spindle properly. If the blade does not sit centrally, it may vibrate or cut unevenly. Maximum speed is equally important. Every blade has a maximum revolutions per minute rating. The saw must not rotate faster than that rating. The blade must also face the correct direction. Match the rotation arrow on the blade with the direction shown on the saw. Inspect the blade for every job. Missing teeth, cracked carbide tips, damaged diamond segments, a bent plate, or an enlarged arbor hole are reasons to stop using it. The blade must also be clean. Resin, adhesive, paint, metal deposits, and compacted dust can coat the teeth and create extra friction. And never force the saw. If the motor slows heavily, the blade wanders, or the material begins burning, stop and identify the cause. More pressure cannot correct a dull blade, unsuitable tooth count, poor alignment, or incorrect material. It only makes the problem happen faster. So the framing blade makes fast, rough construction cuts. The rip blade cuts efficiently along the wood grain. The crosscut blade produces cleaner cuts across the grain. The combination blade handles general workshop jobs without constant blade changes. The fine finish blade protects plywood, laminate, melamine, and visible edges. The non-ferrous metal blade cuts aluminum, brass, and copper. The fiber cement blade survives abrasive cement-based boards. And the diamond blade cuts concrete, brick, tile, and stone. The correct circular saw blade does more than fit onto the arbor. Its tooth count, tooth shape, diameter, material rating, and cutting rim decide how safely the saw's power reaches the workpiece and whether the cut ends cleanly or leaves you with damaged material, a ruined blade, and a much larger problem. If you enjoyed the video and want to support this channel, click the subscribe button so you do not miss any of my future uploads.